I want to say thank you to TranStar for providing a kit for this transmission so that I'd have something to show when going together with it, what a typical rebuild would include. I also want to say thank you to Transgo for providing me with a kit to go through and modify the valve body so that way we get to see what all goes into improving these transmissions, especially the ones that have many miles on it. This transmission that we're looking at here is the GM 6T70, and is very similar in design to the Ford 6F50. And it's actually very similar to the smaller versions of this transmission, which would be like the Ford 6F35 or the GM 6T35, 6T40, 6T45. The operation of this is very similar. The power flow, which clutches are being used, the names of the clutches, how they're driving gear set parts, all that stuff is pretty similar. Matter of fact, there's even a transmission like the Hyundai 6-speed. That's also configured based off of this design that we see here. So if you understand the power flow and the mechanics behind this transmission, it's not that far off from the Ford 6F50, the Ford 6F35, the smaller, the 6T40s, even the Hyundai 6-speed. So let's take a look at this case. This is an all-wheel drive 6T70. The reason why I know that is if we look at this area right here, I got a nice flat section, and this is the spot where a transfer case is going to bolt up to. We also have these splines, a set of splines that exists on this differential gear, so that can provide input to that transfer case. I got my input shaft right here, and it turns. That's a good sign. I got my stator support shaft that supports the stator and the torque converter. That's going to allow it to, the stator, remember, is going to freewheel in that clockwise direction, but it's also going to hold in the counterclockwise direction so we can get that redirection of fluid. And all right, let's rotate this around. This side cover right here, right behind it is going to be our valve body assembly. And on the GM units, they actually put the computer on the valve body. So you're going to find that when we take this apart, there's going to be a solenoid block assembly really, and there's a computer configured into that. There's a computer in that. And you can't even take the solenoids out on this one. It's all kind of a molded assembly. So if you have to replace one solenoid, you actually have to replace that whole assembly. Now in the smaller units, like the 6T40, the solenoids are removable. This one here, this GM that we're looking at, when we pull it out, we'll have a computer and solenoids all built into a casing. This here is the end cover, and quite a bit of this transmission we're going to be taking apart from this end cover. When we pull the end cover out, we'll be able to pull the clutches out, the gear set out, we'll also be able to pull the input drum assembly out and so forth. Now also one thing to notice here is that they have this sticker attached to it, and this says 8 VAK. 8 is going to be the model year for this vehicle. So this one came out of a 2008. VAK is going to be the model designation, so that gives us information on what type of a vehicle it went in. If you have the layout with all the different models, you can find out if this went in an Equinox or a Traverse or a Cruise or something like that. Obviously, a Cruise would use a smaller transmission, but just as an example. When we go to take this apart, we're obviously going to want to use our service manual. We've got actually a student-made service manual. He did a really good job on it by Dan Worminski. I think he graduated in 2018. We don't need that many tools to take this one apart, so we're pretty good with like our 10 millimeters and 8 millimeters and so forth. This little pile right here of special tools helps us install springs and guide pistons down so we don't screw up the seals. And I didn't have every special tool, and those special tools are very expensive. So we made some special tools. All right, let's get everything started by taking this cover off, the side cover. If you have some of these bolts that have this extra stud on them, you might consider marking the side cover with a paint pen or something, so that way you know you can get them in the right spot, because those are likely holding down some kind of a wire clip or a bracket or something like that. I just got these transmissions in a box, so I've got no idea if those are important or not. Here's our pan. It's made out of plastic, nothing fancy. What we're looking at here is the Transmission Electro Hydraulic Control Module, or TECM for short. They got a weird name for that. It doesn't really even spell anything, but That's what they do. Now right here is where the TCM is at. So that's the brains, that's the module right there. And you can see this whole assembly up on top. We've got all these solenoids in here. These solenoids are going to control our shifts, control our pressures, control our torque converter clutch. And we got the computer to control it. And this is the pass-through connector that fits through the side cover. So we have the connection to the rest of the vehicle. We also have a range sensor feeding into that TECM. We also have a speed sensor. We have two speed sensors, one connection here and one connection there. This connection is going to go towards this end cover where we'll have an input shaft speed sensor, and then this speed sensor is going to end up going to the output speed sensor. Ford is going to be a little bit different. It's going to look similar, very similar, but you don't have the computer in there. So you got your solenoid block, you got this plastic casing that goes on top of it, but you don't have the computer built into it. They incorporate that into the PCM. Let's go ahead and take this out. We'll go ahead and take the TECM off first. Gingerly disconnect our wiring harness. This little clip right here is pretty important. They don't want you to forget that. It keeps pressure on this TCM and it helps the heat transfer. So they say you're going to have module failure if you don't put that in there. So that's important. Don't want to leave that out. Here's the big unveiling. We've got this TECM. This is one of the things that makes Generation 1 different from Generation 2, is they have these 4 pressure switches right here. The Generation 2 6070s don't have pressure switches. That is, the pressure switches is something that fails on these. These little filaments that are in there, they end up cracking. And when they crack, they set codes, DTCs. But the good news is the aftermarket has come up with repairs for that, where you can actually take these seals out. Matter of fact, this seal right here is kind of screwed up. If you look, it's bent over right there. So that's not a good sign. You'd never want to put it together without addressing these pressure switches. So those are those pressure switches right in there. And those things like to split. And then if you get those filaments split, then you get all kinds of codes. So you definitely want to address those pressure switches. Here's the rest of the TECM. This assembly right here will need to be reprogrammed if you put a new one in. They're not just plug and play. So you'll need to do a flash programming on these if you end up changing it. So if you want to take the valve body off without taking it off in sections, just kind of take it off in a whole assembly, you'll end up wanting to take these bolts off right around the perimeter pretty much. And then these two right here. The ones I put a red dot on, you could leave. If you could see that red dot okay. We will end up going through the valve body, but just to get to the internals, we'll just take the valve body off in one big old chunk. There's 3 layers to this valve body. At this point, I could just lift this valve body assembly up and take it out of the way. You can see there are the 3 layers of the valve body. I bet you can figure out what the purpose of this valve is. That was the manual valve that linked up right there. I'm going to go ahead and pull these speed sensors out because that way I don't roll it over and accidentally damage them. It's probably a good idea to pull this little seal off right now before you lose it and rolls underneath the bench somewhere. That seals off the valve body passage that goes to the 1, 2, 3, 4 clutch. They describe these sensors as Hall type sensors, but the thing that's interesting is that they only have 2 wires. So I'm not 100% convinced that they're not magnetoresistive. I've never gone through and actually checked them though. Now we got the speed sensors out of the way and we got that little seal out. Let's go ahead and spin this around. And we're going to start taking off the end cover so we can expose our clutches. We could see the pistons that apply some of these clutches. And we can start taking apart this gear set. So here's the end cover on this transmission. A couple things that we can note. We've got 2 pistons in this end cover. This inner piston right here is going to apply this top clutch, and that top clutch is the 2/6 clutch. And then this piston right here has got these little fingers on them, that clutch is actually going to reach down and compress a low reverse clutch assembly. So those are both holding clutches. They're case clutches, so they're designed to stop a gear set part from spinning. This little hub section with Teflon rings, that's going to seal off to this input shaft and this input drum assembly. And in the input drum assembly, we've got two clutches. We've got the 4-5-6 clutch, which is located on the inside, and then on the outside, we've got the 3-5R clutch. We'll go ahead and pull that off. So right here is the 3-5R, applied in third, fifth, or reverse. Figure that out. And then on the inside here, we've got the 4-5-6. We'll put these off to the side because we'll take these apart individually. Now we can start taking some gear set parts out. We'll want to keep track of the direction and where our Torrington bearings go. I'm going to go ahead and, for now, I'm going to build this gear set up on my input shaft. So we take out this rear sun gear assembly. We could take out the 2-6 clutch. You can see I've got 3 frictions, a wave plate. These clutches, although they are, a lot of the splines and the sizes are the same, there's some things that you can note, like the diameter, how wide the friction material is. That'll match up with the clutch disc that it goes on. One thing you might notice, they've got this little angled tab that faces down towards the bottom of the transmission. That will help identify where these steel plates go and how they orient in the case. It's kind of nice having that little tab. So this is our rear carrier, middle internal gear assembly. This is a rear internal gear front carrier, and then tucked in there is a front carrier, and then we also have this middle gear set, which has the front internal gear, the middle carrier. This sun gear lives in the middle, and it's always splined to the input shaft. That was the one I said I was always supplying to the input shaft. Then there's the front sun gear. I'm going to pull out the low reverse clutch pack. There you can see this is my low reverse clutch pack. We've got a wavy plate, and then alternating steels and frictions, all the way up to a backing reaction plate. If you also notice that the steels are thinner and the frictions are a little thinner, so the frictions match up with the steels. There's a little snap ring with a little L shape on it right there. That comes out actually pretty easy, which is hand force. But the opening kind of fits in this area right there. Comes apart, oh goodness. Comes out pretty easy by hand force. Oh wow. Then we can pull the low reverse, the low one-way clutch out. So as you could hear, this is a ratchet type. It holds in one direction, freewheels in the other. And our last set of clutches that are in here are the 1, 2, 3, 4. We've got a wave, 2 frictions, and 2 steels. That one got a little hot. These clutches have been replaced in here, but these steels hadn't, so we probably need new steels. And then lastly, in this half of the case, we've got the piston that applies a 1, 2, 3, 4 holding clutch. It actually comes apart with very little effort. The snap ring that's in there. We do have a special tool to help install it, but it doesn't take much to get this out. There's a snap ring for it. We've got the diaphragm or dished type spring, and then you can grab a pair of pliers. You can grab a pair of pliers and just pull this piston out pretty easily. Or you can blow air into it from the case side. So that's the part that valve body is sealed off on. So the valve body delivered air pressure right through there, got behind this piston, and so if this was fighting you for some reason, which I don't think it would, you can get air pressure in there and pop this piston up. So yeah, that's the piston, the return spring, and the snap ring that goes with it. Get the gasket out of the way. Before you flip the transmission over, take this assembly out. This is what takes torque from the gear set and delivers it to the final drive. If you spin it around with it in there and not thinking that you have to take it out, it lands on the ground, makes a lot of noise. Probably scares you a little bit. At this point we can take this half of the case off and expose the oil pump, the final drive assembly, transfer gears, bearings, all that good stuff. Don't forget you got a bell housing bolt in this little cavity there. All right. Not extremely heavy, but also not extremely light. There's a bell housing bolt that was in that cavity. Inside this half of the case, we've got this transfer tube. Don't want to forget putting that in when you're putting it back together. We have a transfer gear assembly with bearings, parking pawl. We got our final drive assembly with the bearings. You want to inspect those as well. You know, we've just got some seals that we need to make sure we change and don't forget. So after you take the final drive and the transfer gears off, there's really not that much in here, just a bit of cleaning to do. Now that we got the transmission mostly apart, it's time to go through the sub-assemblies. I think I'm going to focus the beginning of this on the front half of the transmission, the bell housing side, so that way we can kind of inspect it, put it back together, and we can actually put it back on the transmission case, so we can free up some space on this bench. And really, because this side, we are only dealing with some bearings, some gears, so some visual inspection basically, and then we also have the oil pump and the filter that we have to deal with. But this is all relatively simple and should be pretty easy to go through. So I'm going to go ahead and pull the oil filter out with the pump by first removing these 10mm bolts. And you can see that this filter is kind of an interference fit there. It gets trapped between the case and the pump when the pump's bolted down, and then when you get the pump off you can just kind of pull it apart. There's a seal that you need to change. Next I'm going to pull these bolts off right here. This will allow me to pull this whole stator support assembly out, and we'll be able to get to the front sprocket, front seal for this transmission. Hopefully you noted the direction of these pump gears. This one actually here has a little dot kind of pressed or pounded into it. Right there for identification. Flip it over, there is no dot on that side. Right here we have a dot. Dot is the dot. So that dot will identify the direction that this gear is supposed to face. And in this case, when I took it apart, that dot was facing up. You're going to want to know which direction the torque converter driven gear is located. And honestly, it wouldn't have hurt if you put like a paint marking or something like that on the actual chain, so that way you can put it in the same direction. The whole idea is that you want drive surfaces matching drive surfaces. If you take this thing apart and you're reusing these and you get them mixed up, because if you look at it, the gear doesn't look like it would hurt anything if you put it the opposite direction. It's not offset from one side to the other. It's still located, the gear itself is located in the middle of this, these raised bosses right here. But if you got one side of the sprocket driving the chain its whole life, it would make sense to continue that. So that way you're not introducing a possible noise or an issue. If you put it back together the same way you took it apart, there's pretty much, if you do have a noise, you know it's not because of this. So marking these things when you take them apart is always a good idea. Even if from the factory, like I said, they put that dot right there, that kind of helps. But you still want to identify the chain, and you still want to identify this torque converter driven sprocket to figure out which direction it was going. That would help minimize any potential noise complaints. So when you go back together with this thing, we're going to look at our thrust washers. These are plastic. As long as these are in good shape, you'll just reuse those. You can change the seal out real easy from the side, just kind of pound it out, and from the back side you'd pound a new seal in. So once you have this all together, you might be wondering, why don't I have a bushing in there supporting this sprocket, the torque converter driven sprocket? It's because the torque converter driven sprocket actually isn't supported by the transmission case. It's supported by the torque converter. And if we look, the torque converter, if I bring one up here, this is the torque converter for that transmission. The torque converter has a bushing on the inside of the hub, and that's not that typical. A lot of times the torque converter bushings are located in the transmission case or in the oil pump, but in this case they put the bushing right there in the hub. And this one's real torn up, it's not in very good shape. And so the stator support, this thing is going to fit around the stator support when it gets assembled. When you actually put the torque converter on the transmission, it fits tight around this. And since this is centering the torque converter can then center the pump gear. So this pump gear is going to be centered on the torque converter. Get in there. This hub has seen better days. There we go. I'm gentle, it'll go in. So the torque converter is going to be driving the sprocket. So the sides of this sprocket actually don't touch the transmission case, because the torque converter is centered on the stator is bolted to the case. So really we just need thruster washers on either side. We don't need to worry about the inside of this case so much. The centering is all taken care of by this torque converter with its bushing and then the stator support. There is a gasket and this rubber seal that will need to be changed out when you're overhauling this transmission. So don't forget to pull this little transfer tube assembly off when you're going through this to make sure you change those seals out. At this point, I'm just going to go ahead and put this back in place. One thing to make note of is when you're going through a transmission, not necessarily every bushing is going to get replaced, but what you're going to want to do is visually inspect these bushings, and then you're going to want to take parts and pieces and maybe put the part that has the bushing in it, put it over the part where it rides, and just feel how loose that feels. Changing every bushing in a transmission is not very practical, it's very time consuming, and some of these bushings just don't see that much wear. So it's pretty common, and sometimes the replacement bushings are not as good as the original quality. So going through and looking and inspecting, looking for scoring, like obviously that one in the torque converter that we looked at was bad shape, so that's not something that you'd want to reuse. But going through like in this stator support right here where the input shaft fits around, you'd want to pay close attention to that bushing, make sure there's not much side clearance, and within the gear set you're going to want to go through and look at those bushings as well. Now I've got this stator support back on and torqued. We're going to go ahead and look at the oil pump itself. If these Torx bolts are really tight, it might help to use an impact driver. It's like one of my favorite tools right here. They're pretty cheap, and they can, especially with Torx bits, you don't want to strip out of Torx, they're kind of a pain to deal with. So using an impact driver, just giving it a couple taps, and then a lot of times they'll loosen them up enough to the point where you can just use a ratchet, or they might just come loose enough where you can unthread it. This might have been easier to do while it was still bolted to the case. If you have tinnitus like I do, you probably want to put earplugs in or earmuffs. If you don't have tinnitus, you're going to want to wear earplugs or earmuffs because this ringing in your ears kind of sucks. These parts a lot of times need to be tapped apart because they're tight. So on the inside here we see the cover, we see a priming spring. This is a variable type pump. We got the pump drive shaft. These little cast iron, this is a sealing ring with an O-ring that fits around it right there. And then this is a vane guide ring. Kind of keeps these vanes out. So this is a variable displacement type pump. Now the sprocket is going to be driving it from this side right here. So that'll be going clockwise. And so the suction occurs on this side of the pump because when this rotates, the area expands where the inlet is, or the suction. So that draws a negative pressure and brings fluid into that pump. And then that pump carries it around and squeezes it out on this side. So we've got inlet and compression. And it is a variable output pump. This spring right here is a priming spring that holds it in maximum output, maximum displacement. And when the transmission is satisfied with the pressure, the valve body is going to divert pressure to this side of this pump slide. And it's going to move this pump slide over, and it's going to equalize the space around this pump. That's pretty typical of a vane type pump. So if I go ahead and pull this priming spring out, you want to kind of keep your fingers on it or else it'll shoot out everywhere. Kill the guy in the stall next to you. Wouldn't want to do that. So you can see that when pressure is applied into this cavity, we're going to be able to move that pump slide back and forth. And it's going to go from minimum displacement, where there's very little output or no output, to maximum displacement. And it's pretty much going to live in a sweet spot where it's going to be generating pretty much just the amount of pressure that the transmission needs. They do these variable displacement pumps because if they are only outputting what pressure they need, they're not unnecessarily creating more pressure and more flow than they need, which is going to be taxing the engine and reducing fuel economy. So you can see right here I've got this orange seal. That orange seal is a kind of a Teflon seal that's going to ride along the side of this bore, and that seals off that pump slide pressure that reduces the pump's output. And then there's a tiny little O-ring in there, and that kind of works like a spring to keep that seal pushed up against the bore. And that's the same premise behind the cast iron ring that we have right here, and then the tiny O-ring that lives behind it. Let me see if I can't get a pick and pull that out. So these things all come in your kit. So that O-ring really works as almost like a spring to kind of push this cast iron ring up against the oil pump cover. So it makes a seal. When we take these pumps apart, we want to inspect pretty much anything visually for damage. This one here, I noticed it's got a blemish on it. Been apart before. I wonder if somebody's got things in there wrong and created an issue. Along that top edge there's a bad spot. I think the ring was in its way and somebody started to tighten the pump down. If you're going to reuse the vanes, similar to as I was explaining to you before about like on the sprocket on the oil pump and the chain, how you want it to pretty much be going the same direction it lived its whole life, I think that's also a good idea for these pump vanes if you end up using them over again. So if you look at these vanes, you can see it's shiny from one side to the other there. That's because it was riding on the inside of this pump slide bore. Whereas on the other side, I could see it shiny only on the ends because that's where these vane rings were in contact. And I can feel just the slightest amount of lip there, so I wouldn't want to install the vanes with the little wear that occurs from the rings. I wouldn't want to have those facing towards the pump slide, because if I had those facing towards the pump slide, it's not going to be a perfect seal all the way across. And I might end up creating some issues, or I might have pump noise, or that little edge might create an accelerated amount of wear on my pump. So you can either get new vanes, of course, but if these things look fine, at least put them in with the smooth side that's all the way across facing the pump slide. That's always a good practice. There's a tiny little Teflon coated bushing in there that you can, once again, if there's no visual issue with it, you can go ahead and put your pump slide in there and you can kind of see if there's excessive side-to-side clearance, if it wobbles. This thing feels pretty good. You're also going to want to inspect the surface to make sure it's not galled up or gouged. If there's any metal that was going through this pump, it's probably going to tear this pump up, create some scoring. I usually use the fingernail test. If it catches a fingernail while I'm dragging it across, it's worn out. Either it could be machined or replaced. All right, so I got my pump ring in there. Now I'm going to install my vanes. I'm going to look at the vanes. There's where my pump ring wear marks are. I'm going to make sure those are facing in towards the center. Do that on all of these. Then when you know you have them all in there, this pump ring, this inner pump ring on the top will fit in there well. And then you can put your O-ring and your outer pump slide cast iron ring in there. I got to get my priming spring in here, and pretty much the easiest trick to doing this is by taking this over to a vise, compressing this spring, and then sliding it into the pump. So I'm going to take my spring, compress it into this vise a little bit, make sure it doesn't shoot out and kill somebody. Then I'll take my pump, bring it right over to it, and just push it in there. Very easy. Now that I've got the priming spring installed, the pump drive shaft is in there, the pump rings, I'm going to start putting this baby together. You got to be careful if you tip this over that you don't knock that pump ring out of position. So I'll squeeze it together and hold it tight, and at least get a bolt started here and there. So that was the oil pump. It's a vane type oil pump. It's variable displacement. This one was in pretty decent shape, so we don't really have to worry too much about it. We'll go ahead and put it back into the bell housing. So we're going to go ahead and take our oil pump, put the new filter with it, position the filter in the case, and the only thing we have to line up is that pump drive shaft to the sprocket. And then we'll tighten our 3 bolts down that retain this oil pump assembly to the front case half. At this point, we have our front case half assembled. We've inspected our oil pump, we've inspected the bushings and our stator support shaft. We looked at the chain and sprocket. We looked at the oil pump. We've got it all assembled. We're also going to want to take a look at any of these bearings on the final drive assembly and on these transfer gears and change them out if necessary. And we've also gone through and changed any of these rubber seals that could potentially cause some leaks. Now we're going to take the rest of these parts that we have here, since we've got the front case half all assembled and ready to go. We're going to go through and start putting things back together on this case half. And so that way we can flip it over and just deal with the gear set. Start by putting our case gasket on there. There are dowel pins to help center these gaskets to make sure they're in the right position. This dowel pin is located on this portion right here, and there's also supposed to be one right there. It looks like it stayed with the front case half, so I got to be aware when I lower this down that this makes its way through that hole, or I could pound that dowel out and push it back in there. But I'm lazy, so I'm not going to do that. Here's our final drive, transfer gear assembly. If you remember, there was a transfer tube that fit in here for lubrication. You don't want to forget to put that in there. That's what this guy's for. All right, and now at this point, we're going to go ahead and put our case half on there. Like a glove. Now that we've got this front case half bolted up there and torqued, we can flip it over and start working on the gear set half. So if we think of the way this gear set is laid out, we've got our input shaft delivering torque all the way through to this drum assembly that's in the back. Here's the original one that came out of the transmission. We got the input shaft delivering torque all the way to the back. We have a 3/5R clutch. And then on the inside here we have a 4/5/6 clutch. The 3/5R clutch is actually going to go in and grab this sun gear assembly. It's a rear sun gear. And the 4/5/6 clutch is going to go in there and grab this rear carrier middle internal gear assembly. So those are our 2 driving clutches. We also have a sun gear that's splined directly to the input shaft to fit around these splines right here. And it's always going to be driven by the input shaft. It's always input, and that lives in the middle gear set. So then we have our 3 holding clutches. We have our 2/6 clutch, just right here towards the back. We have our 2/6 clutch. It's going to basically it's going to hold what the 3/5R clutch drives, and that's the rear sun gear. And then when I have my low reverse clutch assembly, the low reverse clutch works with the low one-way. So the low one-way is mechanical. It basically prevents this rear carrier middle internal gear from ever rotating counterclockwise. But if I apply my low reverse clutch, it's going to prevent that rear carrier middle internal gear from ever rotating. It's just going to lock it. So we actually have to use that in reverse or to get engine braking in first gear. And then in the front we have our 1, 2, 3, 4 clutch. And the 1, 2, 3, 4 clutch grabs onto that front sun gear. And it's going to hold it in first, second, third, and fourth. So I have my 3 holding clutches, 1, 2, 3, 4, low reverse, along with the low one-way roller. And we also have the 2/6 clutch that lives in the back. So 1, 2, 3, 4, low reverse, 2/6. And then our 2 driving clutches are 3/5R on the inside here, and then 4/5/6. So if we go through and do power flow, in first gear I'm going to have my 1, 2, 3, 4 clutch applied. I'm going to have my low reverse clutch holding. Actually, both of these are holding. So my low one-way roller clutch is going to hold, and the low reverse clutch. They actually keep the low reverse clutch on until a few miles an hour, then they release it and just let the low roller hold this. And then my 1, 2, 3, 4 clutch assembly is going to hold that front sun gear. And then this is what my gear reduction would be. If you look at the speed difference between the input shaft and this output assembly for the gear set, this is going to deliver the output to the transfer gears and the final drive and all that good stuff. And this is splined directly to the front carrier and rear internal gear assembly. So it's like a carrier rear internal gear assembly is the output of this gear set. So I'm going to go ahead and put my fingers on the low reverse, where the low reverse clutch would hold on to, and then 1, 2, 3, 4. And you can see this is my gear reduction. So how fast you see the input spinning versus how fast this output assembly is going, that is what the first gear ratio would be. And when I shift in the second, I'm going to release my low reverse, or in the case of the roller clutch, it would just start freewheeling, because you're going to see this little hub, this lug assembly right here, it's going to start rotating clockwise when the 2/6 clutch stops that rear sun gear. So if you remember, the low roller is going to prevent it from spinning counterclockwise, but it won't prevent it from spinning clockwise, and that's what the low roller is going to allow to happen when I'm operating in second gear. So my 1, 2, 3, 4, and my 2/6. So basically, as soon as I apply my 2/6 clutch, my low roller freewheels. All they have to do to get a 1-2 shift is apply the 2/6 clutch. So for third gear, I have to release my 2/6 and apply my 3/5R clutch. So I release this holding clutch and then I drive it at input shaft speed. So I'm going to use this hand to do it because I can't still hold the 1, 2, 3, 4 and drive the input shaft and drive the 3/4. I don't have 3 hands. You probably figured that out by looking. So I'm going to continue to hold the 1, 2, 3, 4 clutch, and my input shaft is going to drive the 3/5R clutch, which is going to drive that rear sun. And this is going to be the third gear rotation, third gear gear reduction. In fourth gear, I'm going to release the 3/5R, and I'm going to apply my 4/5/6, which drives this hub right here towards the middle. And that is going to be fourth gear. In fifth gear, I finally get to release my 1, 2, 3, 4. I'm not holding this anymore. And I'm going to apply my 3/5R. So we have 2 parts input, 2 parts driving, and nothing held. You could probably imagine that gear is my direct drive gear. Everything spins as a unit in that gear. Even if it doesn't look like it is, that's what it would do. It's just having a hard time driving everything evenly. And then lastly, in sixth gear, my 2/6 clutch is going to apply, and my 4/5/6 clutch is the input, and then that gives us the overdrive. You can see the output is spinning faster. It's trying to come apart on me a little bit. So that is overdrive. For reverse, I have to apply and drive my 3/5R clutch, and I have to hold my low reverse. And that will give me my reverse reduction. And you can see that by looking at the output gear, the output splines, and the input shaft. They're going the opposite direction. That's what reverse does for us. Works perfect. My 1, 2, 3, 4 clutch holds the front sun gear assembly. My low reverse clutch holds the middle internal gear rear carrier assembly. The 2/6 clutch holds the rear sun gear. The 3/5R clutch drives the rear sun gear, And the 4-5-6 clutch drives the rear carrier middle internal gear. Let's go ahead and disassemble this gear set. This is towards the front of the transmission right here. This is the output that comes from that rear ring gear assembly, rear internal gear assembly in the front carrier, and delivers torque to the transmission, to the final drive components. And so right here is going to be the front sun gear assembly. And that front sun gear, we've got these splines around the outside. That's where the 1, 2, 3, 4 clutch grabs onto. So that'll be able to stop that sun gear from spinning. It's never driven. And then this is the output gear set. So we've got our front carrier and then rear internal gear assembly. And it's this Torrington bearing right here is what's going to rest on that sun gear. Now, this is the sun gear that's splined to the input shaft of the transmission. So this is always going to receive input. I'll just drop it in there, but realize that this is a component that is always splined to the input shaft, so it's always being driven. And so this is the front internal gear, middle carrier assembly. This is the front internal gear carrier assembly, and it has the lugs that allows the low reverse clutch and the low one-way roller to grab onto it. And then lastly, we've got our rear sun gear. The rear sun gear is, we've got the 3.5R clutch that can drive it and the 2.6 clutch that can hold it. And then this hub, this 4.5-6 hub, gives us the ability to go down and grab onto that rear carrier middle internal gear assembly. So 4.5-6, 3.5R, low reverse and low one-way, 2.6, and 1, 2, 3, 4. When you go through the mechanical parts, like these gear set parts, you want to go through and inspect all these bushings. And sometimes you'll replace the bushings. Some are more susceptible to wear than others. A lot of times through visual inspection you can tell if they've been galled or seem like they've gotten hot. If they still look pretty good, it doesn't hurt to put them on the shaft on where the bushings ride and check for smoothness, check for excessive side clearance, kind of wiggle it side to side. It's not typical that you replace every bushing in a transmission. You'll probably replace the ones that are commonly worn. A lot of times front pump bushings, that kind of stuff. Of course this one's a little different because it's in the converter, but still you want to change the ones that see the most abuse, but a lot of times there's bushings within these transmissions that just don't seem to wear out. The nature of a gear set is that they have a tendency under torque, since you've got these equal planetary gears that are evenly spaced across the central axis of rotation, that under load the force is equal and out in all directions. So that's the reason why you see bushings in a lot of places where, like in a manual transmission, you'll see a bearing. Because bearings, helical cut gears, you're going to have these gears meshing up against each other, and they're going to create a lot of radial force. There's going to be a lot of force pushing out, so you need to have big bearings supporting that. Here, we're splitting that torque evenly across the central axis of rotation, so the torque is going evenly out from the central axis of rotation, so the load isn't so much on these bearings or on the shaft. They kind of self-support and self-float in a sense. But that doesn't mean that there is wear. You obviously want to make sure that these bushings fit with the proper tolerance, so that way these things aren't kind of spinning out of round, which it calls accelerated wear, and fatigue on parts cause them to break eventually. So you still want to inspect bushings. You don't want to just assume because you've got a planetary gear set and it self-centers or so that everything's fine. You want to go through any of these parts that have a bushing in there. You want to go through and make sure that they ride onto their corresponding part and there isn't excessive side clearance or slop or movement. And if they're good, then you move on. If they're bad, you change them. If you look at like the catalogs, like a TranStar catalog, they're going to have everything laid out. So you can buy a bushing kit where you can replace every bushing It comes in a kit, so if you see 4 or 5 that are bad, you might as well get a kit. Otherwise, you might just go out and replace the 1 or 2 that you see that's bad. Yeah, that's pretty typical or common. So at this point, we can go ahead and start putting this transmission back together. We're going to go ahead and put in new pistons. I do have these nice seal installers over here. These seal installers are not cheap. You go to eBay, for example, and you just start looking up the part numbers on these things. Even used, each one of these seal installers are over $100. And one of the things to point out, it's very important, is how fragile some of these seal installers are. If that ever hit the floor, it'd be done. So you definitely want to be really careful with these. You don't want to bang them around. When you're done using them, it's probably good to put them in a safe place so they don't get destroyed. If you don't have a seal installer, there's like some tricks that people have done in the past. This is was a little freebie from a show that Sonics was giving out, but it's basically door ease. There's this material that is pretty commonly used in transmission world. It's called door ease. I think that's a lubricant for door hinges or something like that. And a lot of techs will use that. It's kind of a waxy material. And they'll rub that on the inside of that lip seal. They'll rub it on the inside of that lip seal because it kind of creates a, well, it's like a wax, and it does have a fairly low melting point, so it just dissolves into the transmission. But when you smear that into this lip seal groove, you can kind of squeeze it together, and maybe got a little carried away on that one, but it's supposed to help help you install a piston into a bore. This is the 1, 2, 3, 4 piston. And I got this coated with that lube sealer. It dropped in there easy, but this was also a used piston. Let's try it with a new piston. This is a brand new AC Delco piston that I got from TranStar, and I am going to put a little bit of door ease on there. Sonic's version of door ease. I say a little bit, but I'm getting carried away with it. Kind of rub it into behind that lip seal. Tucking my fingernail in there and getting some of the excess off. And then I'm rubbing my hand around the outside and the inside to helpfully compress that seal into the piston a little bit. And let's see if I can get that in here without damaging this seal, this piston. It dropped in. So the 1, 2, 3, 4 piston, you can get that in there with that door ease, or you could probably use something equivalent to that without necessarily going out and spending $200. This seal installer right here, I believe this is the one. Yeah, this one right here, brand new, is about $225. And on eBay, it seems like people are selling them used for about $125. So is it probably better? Yeah, because the idea behind the seal installer is this fits into the case, that thin piece of metal, and it centers it, and then it's like a cone shape. So it's going to, as you push this down, it's going to let that outer seal kind of collapse in and fit into the bore without causing too much problem. And this gives you something that you can push that piston in with your hand. This also lets you compress the spring, the piston return spring. So anyway, that is a seal installer. So if you're struggling with one of those pistons, you can use that. Otherwise, a little bit of this waxy, like door ease or equivalent, would do a good job of getting that piston in. We're going to start going back together with this transmission, and I want to show you, this is the transmission kit that we are using. It's from TranStar, and obviously this would be similar to any kit suppliers. They use the TransTech seals and gaskets. This is a master overhaul kit. So this master kit included the steels and the frictions. So you can see we've got the steels and the frictions here for every clutch, our 3 holding clutch, our 2 driving clutches. And I'll tell you this right now, I am not going to soak these in transmission fluid. A lot of some builders don't ever soak their frictions, probably because they just don't want to deal with the mess of fluid. Normally I would have, you know, Deck 6 sitting there, and sometimes I take like an old coolant bottle or something like that that's cleaned out, cut the lid off so I can lay them in there, or just have a tray out there with these sitting with oil in it and let them soak. But since this is a lab unit, I'm not going to bother soaking these clutches. Just going to put them in dry, because this isn't actually going to see a vehicle on the road. This is ones that our students go through. Don't fold your kit in half, just to let you know, because it even says that right there. It says gaskets between chipboard. So if I pull this out, I've got the gasket that lives between the case halves. It's got this metal gasket with kind of a built-in rubber seal. So that would go between our case halves. And then this one here goes between our end cover and the transmission case. Once again, since this is a lab unit, I was reusing those, but you'd want to put the fresh gaskets on there on a nice freshly cleaned case. What I'm pointing out here is you don't want to fold your kit in half, because you'll damage these seals. Some of the other things that we have in here, we have the oil pan gasket that'll fit into a groove that goes around the oil pan. So they do give you valve body gaskets. The valve body gaskets that are original are bonded to the separator plates, the little metal plates they have in there. So a lot of techs sometimes will just buy from the dealer or from TranStar new plates, new bonded gasket plates. But if you don't want to mess with that, or you can't get them, they're not available, you can actually scrape off that gasket material off those spacer plates. Or TranStar does sell a chemical that helps break this down and get it off easier, and then you can use gaskets in their place. But I know a lot of builders don't like to spend the time to mess with that, so they just end up ordering new spacer plates. We've got our seals for our input clutch assemblies, the 35R and the 456. We got metal clad seals for like torque converters and axle shafts and all that kind of stuff. These seals right here will fit into the end cover. This is what's going to seal off between the end cover and the input clutch assembly. They are one-piece Teflon seals, so a lot of times you're going to want to use a installer for that slides over it, allows that seal to fall in place, and then a sizer that compresses this back down. This is a gasket right here that is part of the valve body, it's part of the Tecum. So we take the electronic control module off, and it's got this plate right here, so they give you a replacement one for that. More metal clad seals. If you remember, these were on that transfer gear assembly. These are the rubber seals that seal off on that tube that traveled from one half of the case to the other. And we got miscellaneous, you got seals like this that were part of that Stator Support. There's what they call this small parts bag right here. It has another one of those gaskets. And like the pivot rings for the oil pump, little pushing clips to help align the valve body spacer plates to the valve bodies. All these little parts. So this is nice. It's a pretty complete kit. About the only thing you don't see in these kits right here, we've got the seals, the frictions, the valve body gaskets, all the rubber seals. You don't see the pistons. So what you're going to do is you're going to order those pistons separately if you need them. And in most cases, you're going to end up putting new pistons in a transmission. Maybe if it was very low mileage and you're in there to change a part out, you might not do that. So you can order these seals individually, or you can usually get a piston kit that has all the pistons. It's available separately. It's not part of a normal kit. So that way you're not raising the expense up of just the kit if you need it. They actually sell an overhaul kit, which is just basically like the paper, rubber, metal clad seals. Then they have a less steels kit, which is an overhaul kit that comes with everything except the steel plates. And then they sell a master overhaul kit that has the frictions and the steels. And like I said, if you need to order your filter separately and any of these pistons or a whole piston kit, same things with bearings and bushings. You can get bushing kits or bearing kits, but they don't come in these rebuild kits here. So you have to order those individually and separately. And as you look into the catalog, they have the picture of the transmission in the beginning, but then the pages after, you can see the hard parts, the frictions, the clutches, the filters, the kits, the electronics, all that stuff, even tools, they're all listed there itemized in the catalog. Transtar1.com. Let's go ahead and start putting this transmission back together. If you remember where I left off, I was able to install the 1, 2, 3, 4 clutch piston without using their special seal installer. The seal installer would be helpful, but it's not necessary. So we'll go ahead and install this piston with the seal installer since we have them. And we are able to obviously install this without the seal installer. I used a new piston, a little bit of that slippery stick, that Sonic slippery stick, kind of ooze that around the outside edge there. Run my fingers on it to kind of help pull that seal in. But this tool here is going to help guide that outer lip seal into that bore. And you know, you would also want to lubricate this with some Transgel or transmission fluid to help that seal collapse. And the part number for this is J46623-1. Once again, you don't need this tool. You are able to get this one in without using this tool. But with the tool, it will help kind of guide you in there without damaging a lip seal. So the chances of you damaging the lip seal using the special tools, pretty slim. It just dropped right in pretty easy. All right, now next we're going to install the diaphragm spring. And they have these little notches, these cutouts that the spring lays in. So I'm going to go ahead and put this down in there. You can see it doesn't find the snap ring groove because I need to compress the spring a little bit. And once again, this special tool, there's a special tool for that. This one here is J46632, and this will sit on that spring. And then we would use a bar to push down on the center of this. The tool they show in the service manual is this it's a DT48056. You'd find a couple cover bolts, thread that in, and then you just thread this down and it pushes down on this spring compressor, and that allows you to get the snap ring in. But if you take a close look at this, you can see without the snap ring installed that the actual snap ring groove is just barely below the spring, so it doesn't take that much effort. The tool that pushes down on it does work, and also you can see that the snap ring groove isn't very deep. If I pull this spring out, you can kind of see that snap ring groove is pretty shallow that it lives in. So don't expect the snap ring to fit in there very far. I found that if you start at the snap ring openings, push them down, get them in there, and work your way around, kind of towards the opposite end of the snap ring, and then work your way back with a snap ring tool, like a small, like a screwdriver or something like that, that works pretty good. So I'm going to push this in to start with here. Oh goodness. Once again, doing all this without the special tool. I like to kind of push it in the opposite direction either way to kind of force that in the snap ring groove, but that's it. That's as far as it fits. So before I go any further, I think I'm going to go ahead and put some of these gear set parts in there. It'd probably make it easier when we're going together with this to have those gear set parts taken care of. This is that output hub. That output hub is basically the part that delivers torque from my gear set to all my final drive stuff. This is going to fit with the outer bearing race laying in a machine pocket. So it'll actually sit like that. This little raised lip fits into a little like spot for it. There's no snap ring that retains this. It just kind of sits on in there. Okay, now I'm going to go ahead and put my sun gear assembly over that. And I can go ahead and build up my 1, 2, 3, 4 clutch assembly. So now we're going to go ahead and go back together with this. I have my sun gear installed. I got the piston installed with the snap ring. In the master kit, it does not come with the wave plate. If I needed a wave plate, I would have had to have ordered that separately. I'm going to go ahead and start with it, put it in. This little tab that they give you there, if the steel plate or the wave plates have that tab, it faces towards the bottom of the case. And you're going to see that the replacement steels do not include that tab. So you're kind of left to trying to figure out exactly where they go. It's not too hard to figure out though. Spoke too soon. There we go. So it's friction, wave, steel, friction, steel. So I'm going to go ahead and start installing some of these gear set parts. And remember your Torrington bearings. I've got Torrington bearings separating all these rotating parts. They're pretty obvious where the bearings go. If you need to, use Transgel to stick these on there. These parts can be assembled in different order than what I'm doing it, but this is just how I'm doing it. And this is the low one-way diode. You can see here that ratcheting. It allows the gear set to spin clockwise viewed from the front and holds counterclockwise. Of course, I'm looking at it from the back right now, so it looks a little different. Drop this assembly into place, and then I can install my snap ring. This little tab is going to fit inside this opening here. So you want the tab to be referencing from the bottom of the transmission case, which is here. That tab's about the 2 o'clock position, and the opening is at about the 3 o'clock position. If you're doing the 6F50, it's a little different. They have a spot that prevents you from putting the opening of the snap ring anywhere else other than that one spot. At least that's the intent. I'm going to go ahead and put my middle internal gear rear carrier assembly in. Next, I'm going to install my low reverse clutch assembly. We're going to start with this reaction plate or backing plate, and it's got this tab right there that identifies that goes towards the bottom of the case. And if you also notice on it, there's a recess or a step on it. That step is there so it captures that snap ring that holds the little roller in place. So we'll drop that down, and then we'll alternate friction, steel. And then I have this apply plate. This apply plate is actually thicker than all the other steel plates. It has the same lug pattern, but it's a little thicker plate. This is what kind of is going to apply the force to apply this clutch from the fingers from the end cover where the piston is. So I'll put that in, and then on top of this apply plate I'm going to put my cushion spring. This is that wavy type steel plate. It's not supposed to be flat, it's got a little curve to it. So that's intended to be like that. And as I mentioned, I think before, so also there is no clutch clearance specifications that they provide. There's no adjustment to these, so if something is not right, that means something is assembled wrong. How about that? Lastly, we're going to put in our 2/6 clutch assembly. So we're going to start with the backing plate for that clutch assembly. So we got the tab at that 6 o'clock position. Then I'll alternate my friction, steel, and lastly, we've got our wave. So at this point, I've got all my clutches in there, all the holding clutches, all the case clutches. And this right here is going to be the rear sun gear assembly. Let's spin this in place. Trying to line up those clutch discs. Get that seated all the way. And then on the input drum assembly, I've got my thrust washer, my Torrington bearing that rides with this. At this point, what we have to do is we have to address the end cover, the 2 pistons that we have in the end cover, and we also have to take apart the input drum assembly that has the 3.5R clutch and the 4.5/6 clutch, and we'll go through and replace the pistons and seals and all that good stuff in those, and then we're ready to put this on and be done with the gear train. Alright, we're going to start with this end cover. We've got 2 pistons in it. We've got the low reverse and the 2/6, and then we're going to move over to the input drum that has the 3.5R and the 4.5/6 clutch. So first with the end cover we're going to take the snap ring off on the outside here. There is a diaphragm type spring in there, but there's not a lot of tension on it. You'll see when we get the snap ring out, it doesn't, come on, it doesn't just launch out of there. Oh gosh. It doesn't really launch out of there too bad. And this is the diaphragm spring that we have under it. Everything's fighting me today. So here's the diaphragm spring under it. And this is the low reverse piston. If I look at this piston, I actually have there's a bleed hole right there, right in this spot. And that's supposed to line up to this casting right here, that casting flash. So this bleed hole that we have, and that little spot right there, that lines up with this casting right there. And that lets air bleed out when this clutch fills up. Put that off to the side, and then now we have our 2/6 piston, and the spring that's in there is captured between the housing and the spring assembly. So I actually need to use a press. I got a little screw press here that'll let us take that off. And they do have a special tool for it, which is handy. It is this little tool here. It's the same one we use to deal with the 1, 2, 3, 4 spring, which we really didn't need for it, but it fit for that. One in the case. Don't want to get too carried away because you don't want to bend this snap ring. Oh, there we go. All right. Ta-da. Here is that spring assembly. Bunch of little springs. That returns this 2/6 piston. When we go to install the new piston, I'm going to use my little sonic slippery stick. Get some of that wax around there, and then I'll work it in. Kind of helps squeeze that seal together. There is nothing to line up on this piston because in the housing there's a little spot right there, and there, across from that, inside the 2/6 piston cavity, there's a small little hole. So any air that gets in there is going to bleed out into the center section, and the 3.5R 456 input drum assembly lives in the center section, so that doesn't really do anything. Now they do have a seal installer for this, but kind of like all these others, you really don't need it. If you kind of are patient and gingerly work this, I like to kind of pull it back and forth in different spots, and that usually walks that seal right over any kind of difficult spots, and that drops right in. And that is with the new seal. It's not like I'm using one that's been in there for a while and is easy to compress. So now we're going to go back together with it. And this tool, I'll put the measurements up there in case you need to find something similar. But you can always get it. It's the 466-32 J tool. This one I think would be handy to have because compressing this is difficult. I don't know how you do it unless you found a drum, something that was of equivalent size. Snap ring does not have that much strength to it or tension to it, so it's pretty easy to just kind of, with thumb force, pop that into the groove. So now we have the 2/6 piston installed. Next we're going to go ahead and install the low reverse. If you remember when I took it apart, this is the one where I do have to line up a hole. This little circular cutout that I've got. So this rough spot in the casting has to line up with this kind of notch that they put in the piston and the hole, the bleed hole. That way, a couple things. One is we know that these fingers are going to be in the right spot, so when we drop our end cover on there, everything's going to be lined up. Two, it's going to position that bleed hole in the spot that they want it. There is a seal installer for it, a piston installer, kind of fits over there. And these things, basically what they're doing is that they're allowing it to skip over the snap ring groove that's in there. But that snap ring groove is not really an issue because the snap ring groove lives there, and then the bore chokes down, actually becomes a little more narrow, and they do it on an angle, so there's actually kind of like a built-in seal installer on this. I don't see where you're going to catch the piston into that snap ring groove. So I don't see you can see it dropped in super easy. This compressing the diaphragm spring is a little difficult, but it's not impossible. The trick is to keep the spring from getting pushed off to one side, because if it gets pushed off to one side, the edge of the spring might go into the snap ring groove. Then of course it's impossible to install the snap ring. So when you do this, you start it, you push down, and if it gets to the point where it's difficult to get in, you'll probably have a shifted spring, and you just need to go in there with the screwdriver and kind of tweak the spring into its centered position, and then you'll have access. Like I'm still able to go in pretty good right now. I'm all set to this side right now, so I'll go in there with the screwdriver and kind of wedge and shift the spring. Just basically go around it and recenter it. You can always shift it really to the side that you already have the snap ring in its groove, because you know that is far enough. That's, you can't slide into the groove if the snap ring already occupies it. So I'm kind of going in between the fingers and the 2/6 piston and sliding it over. And there we have it. It's all the way in there, all the way around. This center section that we have right here is the centering hub, if you will, that my 3.5R and my 4.56 input drum, that's how it gets fluid to these pistons to apply these clutches. You can take this off. The seals are one-piece seals. They do have an installer for those seals, and the part number on it is the J46620-1. The 20-3 and 20-2 are the tool that allows you to slide it over. And there's a tool that kind of covers this, and then a tool that helps you slide the new ring on. When you slide a new ring on, it's going to be stretched out. So they want you to use the sizer to kind of compress it. They've got two sides of the sizer. This is a chamfered side, a large chamfer, and this is a small chamfer. The way they explain it in the service manual is you use the large chamfer, push it down. Now, of course, if it's sticking really far out, you're supposed to work it into the groove with your fingers first. And they want you to leave it on that ring for 60 seconds. Then slide it off, flip it over where the small chamfer is, do the same thing, and leave it on there for 60 seconds. But they don't want you to leave it on there any longer than 60 seconds, because if they say if you leave it on there more than 60 seconds, it'll be shrunk too much, and it'll leak so much when you first start, you might burn the transmission up in the very beginning of the test drive or something like that until it has a chance to expand. So, but yeah, that's the sizer. I know a lot of people, myself included, didn't have the sizer. They might wrap electrical tape around it and a hose clamp or something to kind of make a makeshift seal installer, and that kind of works at times. So at this point, my end cover is complete. I've got the new pistons in there, snap rings installed, everything looks good. I have not air tested this yet. If you remember on other lectures, we talked about you really aren't supposed to air test pistons that don't have anything to work against, meaning we don't have a clutch to work against or anything like that. So here, these pistons are pushing up into midair. There's no clutches here for them to squeeze up against. So if you were to air check this, you would want to do it with a very low amount of air pressure. Just kind of bleed it in, let it slowly come up, and just to check to see if you've got any gross leaks. Now, you will expect to hear a leak through this little passage in the middle. One little trick is to grab an eraser, like those erasers that you have at school, the little rubbery type erasers, lay that across the section to seal it off, and then just put 5 psi in there or something just to see if you've got any leaks. Can't really get the best seal with my air gun. But just kind of slowly bleeding some of this pressure in. Most of that leakage is coming from around the tip. I don't have a good, this is too big and that's too small. Go figure. So at this point, we're going to move over to our input drum assembly. So I'm going to deal with the 456 first, mainly because that's a little simpler. I can pull the clutch assembly out. This is the hub. Got the little Torrington bearing that fits inside this hub assembly. I keep that close by. This also has these tiny little tabs, kind of like the 41 TE has. So that way when you go to install the drum, it just doesn't fall out. If I'm installing it when it's sitting inside the transmission case and I go install it this way, it keeps the hub from falling out. So all I have to do is line up these splines. Also, I would want to inspect these bushings that we have in here and make sure that they feel good. You can lay that on there and check for side clearance, side-to-side movement. See if there's anything excessive. Also just look at it to see the condition of it. Now I do need to compress this little oil dam, they would call it. It's kind of like a compensator piston. And the snap ring is tucked in there. I can't get to it without pushing this little dam assembly down. Excuse my language. So I'm going to go ahead and use my screw press. Because it's portable, it's handy, it's right here. This requires me to use a kind of a homemade special tool. There is a special tool that they sell for it, but if you are at a trans shop, you likely have parts laying around that will work. Many of you would have a 4T65 hub that's probably been sheared off at the end where the splines are. And this is just a 46RE or, equivalent overdrive thrust bearing. And I have a bunch of these that are all the same thickness, so I welded that onto the bottom there. I welded a little extension onto this to make it a little easier for me to get to. So I'm going to use my screw press and my little homemade special tool here to just press this oil dam down far enough that I can get this snap ring out. And I cut reliefs out on both sides of this 4T65 drum. Get my snap ring pliers in there, spread it open. And there we go. It's fun when you can save a little bit of money by making a special tool. It's not a very complicated tool. We just need something to overcome the tension of these little coil springs. Because all that we did was we compressed this down far enough to get this snap ring out of that recess. If this piston doesn't come out easily, you could put it into the end cover and let air pressure blow it out. And there you have it. This is the 456 piston. And in the kit, we'll have replacement seals. This is a D-ring type shaped seal, and then this one here, it's actually a D-shaped ring too, so we got this orange coated D-ring. Fits along the outside, and we've got just the natural colored O-ring fitting around the lower half of that piston. So we got two seals on that piston. On the inside of the drum, there's also another sealing ring. Don't want to forget that. And you can see it's also a D-shaped seal. Squared off on the inside, rounded on the outside. This is the input drum assembly that seems to get damaged when the wave plate breaks. It's an issue that GM has. It doesn't seem to affect Ford. The Ford wave springs are different. They've made them thicker. Even though they designed this together, they still had their differences. They do have a seal installer for this piston. It is part number DT47859. Kind of like the other seals, this one guides along on the outer bore here, but there's already a chamfer cut into this piston. There's no snap ring grooves that you have to worry about, so I don't really see the necessity of that tool. And you can get that in there. It does take a little bit of force because unlike it just being a lip seal, these are like D-rings, so they kind of compress and they're snug into the bore. Put it back together with our snap ring and our oil dam retainer. So they can control the amount of oil on the other side of this piston through this oil dam assembly. There's actually a passageway there and it's fed through the case cover. So you'll see that on some of these transmissions where that is a way to kind of balance this piston, especially when it's not being used. They can have this circuit filled with oil, and so that way centrifugal force is going to help keep that piston released. And then when they apply it, they can just make sure there's no pressure behind this on the other side of this piston, on the spring side of this piston. And that's just kind of a way to dampen and control the hydraulics in these transmissions. So we're going to kind of guide that one on there, pushing it down, getting it started by hand, which is working fine. And then I'll have to use my screw press. And I will use the screw press to compress the rest of the way and install it. My homemade special tool. At this point, we replaced the 456 piston and reinstalled the piston assembly with its seals. Now we have to deal with the 35R. The 35R, it looks like, there's a snap ring right here. We'll get that off. You can probably work at it to get the snap ring off, but the service manual is going to want you to take this piston assembly off from the back side first. And in order to do that, we have to compress this reluctor wheel down. And I'll use my little press with that hole lined up to do that. Now it's time to pull this reluctor ring off so we can get the 3.5R piston out, and then we can get the 3.5R clutches out. And I have a homemade tool for this. It is, and I'm sure you have something laying around that will work. Basically what we need to do is push down on this reluctor wheel just enough to get the snap ring out. You don't want to push it down too much because there's a tab right here, and that tab could break off. It's just a little piece of, looks like cast iron or something that's kind of hanging into this opening. And if you over compress this, you pop that off. So this right here is a 1, 2, 3, 4 hub off of a 6L80. I have spare parts for those laying around. But I think it measures to be about, I don't know, anything larger than 5.5 inches, probably 5.5 to 6 inches in diameter you can use to push down on this. And I cut a little window out here so that way I can get a pair of snap ring pliers in there to open that up. Once again, does not take a lot of force. I'm just basically pushing that down to give myself access so I can get the snap ring out. The neat thing about these drums is they've already have holes cut in them so you can get your fingers in there and pop that snap ring out, so not too bad. At this point we can pull this reluctor wheel off. Sometimes it doesn't come out super easy. In this case it came out pretty easy. You can see here's that reluctor wheel. The piston fits inside this surface right here. Let me pull the 3.5R piston off. So here's the 3.5R piston. The inner seal actually fits inside the reluctor wheel. And that's what this orange O-ring is sealing off, where the reluctor wheel sits in there, so that way there won't be any leaks. So this is the reluctor wheel / inner seal housing, and then this is the 3.5R piston right here. Piston return spring. So with all that removed, I can gain access to my snap ring a little easier. Like I said, if you worked at it, you could probably get that snap ring off anyway, but it seems to be a little easier if you pull the piston out first. And here you have the clutches. This is the wave that commonly breaks and tears up the drum. So when we go back together with it, if you haven't already bought a new wave plate, like if it wasn't broken to begin with, you definitely want to put the updated wave plate in there. And a lot of times the reason why you're going through this is because it did break the wave plate, and now you're going back together with a new drum. This is the damage that was on the original drum that was in this transmission. You could see it tore up. That wave plate, when it broke, it went around and tore up this drum where the 3.5R steels and clutches live. So normally there'd be a shaft in here, but if you remember, I pressed that shaft out so I can use it during power flow. So I'm going to go back together with a new clutch assembly. So I start out with a wave plate, then I put a steel, friction, and alternate. You do that all the way up to the backing plate, and then I can put my snap ring back in. So while I'm here, I'm going to go ahead and put my 456 clutch back in, and I'm going to want to have the hub in place because if you remember, they have these 3 little tabs on there that prevent you from pulling this hub out, so that way it doesn't fall out. I also need to make sure I got my Torrington bearing in there. And you alternate steel and friction. There is no wave plate that goes with the 456 clutch. And we finish with our backing plate. And put our snap ring in there. And that would be our 456. So now we got our clutches built up. Let's go ahead and put our 3.5R piston. And of course we would replace these seals. So kind of like on the 456 clutch, we have a natural colored O-ring type / D-ring type seal. It's rounded on the outside edge and kind of, it's actually got kind of an internal curvature on the inside edge. So that's a fancy seal going on there. So this orange seal here has got a rounded outside to it, and it's squared off on the inside. That goes in this top groove. So they do have a seal installed for this, but it is, I don't really know why you need to use it. Basically it's to help this piston drop into the Reluctor wheel. You can see it just falls in there anyway. Now this is the original piston. Let me grab the new one. We'll see how it does. Just falls right in. You're supposed to put this little plastic helper, seal helper, inside the Reluctor ring like that. And it is supposed to have that split right there. And then this is supposed to help guide that lip seal in. Kind of like that, I guess. And then you pull your seal installer back out. I don't know. Don't spend money on a seal installer for it, because the piston, it just goes in there fine. So we're going to go ahead and put our spring, our piston return spring down there. We want to line up our tab to the slot. Here's the slot, there's the tab. And we push that right down onto it. And we have to compress this so we can get our snap ring back in. Use my modified tool, homemade tool. Once again, only tight enough to get it down to the point where that tab is in contact with the drum, because we don't want to break that tab off. You can slide it with your fingers, pretty easy. 6L80 1, 2, 3, 4 drum with a notch cut out of it. The 35R apply plate, it actually fits right inside and grabs onto that 2.6 piston spring really well. So this is a part you probably have laying around that if you work on transmissions a lot, you can use it to help you take that spring out, which, like I said, is probably the only special tool that you really could benefit from, is a tool to press onto that spring so we can get that snap ring out. Okay, so at this point I've got my input drum built, and now I'm going to want to air test it to make sure it's all good. We'll use the end cover to air test it. I'm going to stick my Torrington bearing in place so that we know it's all at the proper height. And I'll use my air to test. Well, we could test all of the pistons. Remember, these pistons that are in the end cover, they don't have a clutch to work up against, so we got to be real gentle when we apply that. Whereas the drum, the input drum, we've got the snap rings and the clutches, everything's in there, so we can just go full bore and apply, you know. Still, you only usually apply 30, 40 psi. You want to make sure it has the ability to apply a clutch at low pressure, like 30 to 40 psi. Because with air pressure, obviously it'll leak out easier through some kind of an orifice or a hole. So if you applied it with shop air and it actually had a real leak, like it was leaking around the seals, it would still probably be able to apply that piston because of the volume of air. So we want to test it at a lower pressure, usually around 30 to 40 psi. I'm going to try this Sonex air plate to see if I can seal it off well enough. Below reverse. 4, 5, 6. 2, 6. Got my 3.5R applying, and then this is actually the compensator side of the 4.5.6. We can actually hear it apply. So we've got our input drum air test fine, our end cover air test fine. We're ready to put the input drum back into the transmission, put the end cover in with its new gasket, and then we'll move on to the valve body. We're back at the transmission. We're ready to install our input drum assembly. And I'm going to go ahead and put some Transgel, kind of stick this Torrington bearing in place. So that's the first thing that we're going to need to do, is get this installed back into the transmission. And then next, we got to put our gasket in place. There's a dowel pin right here that centers it. So now I'm going to drop my end cover in place. And place the bolts. Okay, I tried to label these. I didn't do a very good job, but this is the torque sequence they want you to go to. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I don't know how many of you are going to go through and do that, but you know, I'd say get yourself a star pattern and you'll probably be fine. All right, now we're ready for the valve body. And while we're at it, let's go ahead and put our speed sensor into place. I actually have a special tool to help you fish this speed sensor through here. Kind of like most special tools in this transmission. Not really necessary, you can just pull it through. Another seal you're not going to want to forget is this bridge seal that goes between the valve body and the casting there, so that way you have the ability to apply your 1, 2, 3, 4 clutch. Without that, you'll just leak all that out. That wouldn't be good. Before we put the valve body on, we're going to go ahead and take it apart, go through it, take a look at some of the important valves. We're going to vacuum check it to see if there's any worn out bores. And there's going to be a companion video to this where we're going to go through the process of installing a Transgo kit, the improver kit, the kit that corrects for a lot of issues that they've got in these transmissions. And in that video also, we'll talk to an engineer from Transgo and I'll ask them some questions, and we'll get a little bit of feedback on how they came up with that kit and how they're addressing some of the major issues with that. So look for that companion video, because that's going to accompany this transmission, and it's going to focus really on the valve body modifications. Now we're going to go through the valve body and take it apart, clean it, inspect the bores, do a vacuum test on it, and when we're done and we put this back together, I'm going to go ahead and install a Transgo shift kit. This kit right here addresses the issues in the Generation 1 6T70, and it'll go through and fix some of the common issues that they have. They address the torque converter clutch valve, they address the AFL valve in there, actuator feed limit. They also address the pressure regulator valve. So there's a few things that this kit will correct for in there, and we'll go through the process of installing that too. If you remember, this assembly right here is the TECM, and this is the component that includes the transmission control module, has all the different solenoids. You can see right there is a thermistor for checking temperature. And the disadvantage to this is that you can't replace any of these solenoids. It's all in this one big plastic casing. So if you have an issue with anything, you have to replace the whole thing. Now, towards the end of this video, we're going to go through and address these pressure switches. These pressure switches are serviceable. There's something that you can actually go through and fix and change in here. And that is a common issue with these Generation 1 6T70s, is they crack those pressure switch films, and then they'll set all kinds of pressure switch codes. And you know, until they came up with a repair for that, the only way to address that was to replace this whole TECM assembly, which, you know, could run $400 to $800 or so, depending on your supplier, whether you're getting OE or if you're getting a Dorman, you know, an aftermarket version of this. Usually I would tell students that a bolt sticks out about the thickness of the head of the bolt. If you look, most of these are right there, right? You know, if you're just kind of putting things together and trying to figure out, like, do I have them in the right spot? I mean, it's not set in stone, but these three right here have kind of their own little shallow threaded spots, and they don't fit that rule at all. So you can actually, I don't know if it shows up on camera, but you could see the division between kind of the virgin threads and then the ones that's been threaded into the aluminum. It's not that they were in the wrong spot, it's just that that's what they put in there. They ended up threading the whole thing, which is kind of odd. But okay, we'll pull these out. It's our channel casting cover. This is just our channel plate. Inside the channel plate, what we have are 3 solenoid accumulators, if you will. From a previous installation, I have transgel in there to keep them from falling out. But you can see it's just a tiny little spring and a tiny little piston. There's not much happening there. Here's one of those bonded gaskets. This is my upper valve body. There are 9 check balls in this valve body, and they're kind of tucked into these nice little passageways there. And then separating the lower valve body and the upper valve body, we've got another bonded gasket. This is the 4.5 accumulator. It's like the only real accumulator this transmission has. And this is the 4.5/6 accumulator boost valve train, they call it. Next along this line is the actuator feed limit valve train. And then we have the 3.5R boost valve train. And this one is the 1, 2, 3, 4 boost valve train. And this last one in here is the 1, 2, 3, 4 regulator valve train. So we'll clean out the valve body casting and the valves so that way we can perform a vacuum test on it to see if any of the bores are worn out. Okay, now that these are cleaned, we're going to go ahead and reassemble it so we can do our vacuum test. There we have it. Now we've got this valve body assembled, and I can go through and vacuum test these passages to see if these bores are worn out. The vacuum tests do a good job to find out if these bores are worn out, and that might point you to a direction if that matches the symptom or the complaint on this transmission. If you've got a clutch that burnt up, or hard shift, soft shift, and you've got a valve that's responsible for that clutch, and when you vacuum check it, it's worn out, that might be the root cause. That's where this Transgo kit, it will come in and it'll address some of those issues. So, and it's always a good idea to know if this Transgo kit is going to address the issues. Instead of just putting the kit in and not checking, you'd be better off putting doing a check, seeing if it's worn out, so that way you'll be a little bit more confident that your repairs are going to address the original complaint of the transmission. So, okay, I'm going to put this off to the side so we can vacuum check both of them at the same time. So now I got my upper valve body completely disassembled, laid out here on the tray. We're going to go ahead and identify these parts. And this is the first reverse 4.5/6 clutch regulator apply valve train. And this one's the torque converter clutch regulator apply valve train. This one here is the 2.6 valve train. And this one here is the 3.5R regulator valve train. This is my pressure regulator. I've got an isolator valve right there. Torque converter clutch control valve train, 2 clutch select switches, and my manual valve. That's the easy one right there, manual valve. So now we're going to put this back together so we can go through and vacuum test both valve bodies and see if any of these valve body bores are worn out. Well, now the valve bodies are back together. Let's head over and do some vacuum tests, and we'll see what kind of results we get here. So here I have an old vacuum pump. This is I don't know, it was about 1 million years old, and I've converted this to work with my vacuum test station. But what we basically have here is the vacuum is going to pull through this air bleed valve, go into this vacuum gauge, or read off this vacuum gauge, then go into this air bleed valve. So I'm going to basically plug off this passage here and adjust this valve that says 25 on it. I'm going to adjust it until I get 25 inches of vacuum. So anything, this vacuum pump, if it's really strong, I'll open this air bleed valve up more and let it leak some of it out to the point where I only read 25 inches of vacuum. And then when I take my thumb off of this, and this piece, by the way, is an orifice. It's a cup plug that I pushed in there that has a 40 thousandths hole drilled through it. So when this thing is installed into that vacuum line, we've got and it's pulling vacuum, I've got a 40 thousandths leak that's going to exist here. So I'm going to adjust this valve until I get 5 inches of vacuum. So a perfect seal would be 25 inches of vacuum. A 40 thousandths leak will be 5 inches of vacuum. And the reason why I do that is that way I can take any vacuum pump that I've got and make it work pretty much the same. You know, if I've got 5 different setups, they're all going to be repeatable measurements. So let's go ahead and adjust this. So this one would be the 5 inches of vacuum, which it already was pretty close. And then if I put my thumb over the end, see it's reading higher than 25, so I'll bleed off some vacuum until I get 25. I go back and forth in case I need to fine tune it. It's actually a good idea to check this. If you're running this machine or the pump for a while, you should probably check it a couple times. Plus that's repeatable. A perfect seal is going to give me 25 inches of vacuum. A 40 thousandths hole is going to give me 5 inches of vacuum. So now I can go through and test these bores in this valve body. If I have a leak that's equal to 40 thousandths of an inch of a hole in diameter, that's going to show me 5 inches of vacuum. If the leak's greater than that, it's going to be less than 5 inches. If it's a perfect seal, it's going to show me 25 inches of vacuum. So I'm going to expect somewhere between 25 and 0. So normally we're going to be expecting these little passages to seal fairly well. So you'll see specs ranging from 14 inches, 16 inches, 18 inches, 20 inches, and we'll look at these for the individual passages. This first passage that I'm checking is the pressure regulator circuit. So I'm getting 21 inches. The second passage, I got 19 inches of vacuum. This next circuit is the torque converter clutch control circuit, right here. Got 23 inches of vacuum. These are end plugs, and on these, some of these end plugs, I actually have to put my finger over the end hole. So that's got a good strong seal. That one's about 22 inches. About 23 inches on that one. This is the torque converter clutch regulator circuit. 24 inches. More on the torque converter clutch regulator circuit. That one's only giving me about 17 inches of vacuum. That one's a little low. This is the 2.6 regulator circuit. So I got about 20 inches here, that's good. 18 inches on the end. And this last one here is the 3.5R. We have 21 inches. Supposed to be able to get 20. This one will be a little trickier. This is a long passageway, and I'm getting 21 inches of vacuum on it too. So this thing, the only thing that really didn't test out very well is the torque converter clutch regulator circuit. Looking at my lower valve body, this circuit here is my clutch boost. And I was supposed to get 16, and it looks like I'm getting 19, so that's good. More on the clutch boost. This one here, got to cover the other side of the valve body on this one. 22 is good. I should get 16 on this. I'm getting 19. Should get 18 on that one. This one should have 18 inches. Got good 18 inches there. This passage right here these are all part of the clutch boost. These are all clutch boost circuits. 20. This one right here is the AFL valve, actuator feed limit. I'm getting 15 inches. That one's supposed to get 18, so that one's a little low. So there's one that I'd want to address right there, AFL. This end plug right here, I should get 18 inches of vacuum. I'm getting 24s. Very strong. And this is my 456 accumulator. And it's got 23 inches of vacuum. So after finishing this, it seems like the only two valves that really have issues are my actuator feed limit and my torque converter clutch regulator circuit. So those I'll definitely need to address to make sure that they seal up well enough, especially if those relate to the root cause of the failure of this transmission. We've got our vacuum test results, and like I mentioned before, we've got a torque converter clutch regulator circuit and an AFL valve that kind of failed the test. So we're going to go through and we're going to install this Transgo kit. This is the SK6070-A, and it's for the Generation 1 2007 on unit. So they have you go through and identify. That's actually one of the things they have you do in the instructions first. So they go through and say, hey, do you have pressure switches? If you do have pressure switches in your valve body or on the Tecum, then you do have a Gen 1 and you go ahead and use this kit. But you do want to make sure you're using the right kit because Gen 2 doesn't use pressure switches. They change some of the valving around and so forth. So let's go ahead and see what kind of goodies we got in this here bag. So the kit's nice. It provides 4 new valves, a new spring and retainer, and then the pressure switches. But one of the things you want to do is if you take one of these Transgo kits, you want to install the whole kit. You don't want to just piecemeal, put one piece in here or there. Like if this just failed the torque converter clutch regulator circuit and the AFL, I don't think I'd want to just replace those two. I think I'm going to want to go through and do everything because they're kind of designed to work in conjunction with each other. Like we get a new pressure regulator valve assembly in here, and maybe that's going to change the pressures a little bit. So that is maybe why you have to adjust and change some of the other valves so that they're designed to work along with it. One of the first things they have you do in the instructions is they want you to look at this lineup, this valve lineup for the torque converter clutch regulator to see if it's an open casting or to see if there's a step in there. And on this one, it's an open casting. There is no step. It's just wide open. If there was a step, you'd see some aluminum in there. If it did have a step there, they'd want you to reuse the original retainer and spring. But since it doesn't have a step, they want you to go through and take the spring out, discard, and then use their retainer and their spring. And the reason why, I assume, don't know for sure, is that this has the ability to center that spring. That spring kind of fits in there weird up against this plate. But here, we've got a little recess for that spring to sit in, so that way it doesn't get cocked. Make sure that spring is centered in that little cup there. And we got a new spring there. There we go, perfect. Should be good. So now we can get rid of this spring and this retainer. I'll just put these off to the side. So next they're going to want you to deal with this isolator valve. So we have our isolator valve spring and end plug with the retainer. So this is the new setup here. And we're going to put the spring in first. Then we'll have a little check ball there. That'll sit in the end, in the spring, and then the retainer will fit in this groove right there to kind of retain this whole assembly. Put a little dab of Trans gel in there, keep that check ball from falling out. The spring. I'll slide that into my isolator circuit there. Push it in far enough to get my clip in. There we have that. So there's where my isolator valve went into. Alright, so we finished putting the isolator valve in there. Next, let's move over to the pressure regulator. It's a typical type GM valve where the line pressure comes in through this tiny little hole, finds its way out to the end of the valve, and that's what works on the end of the valve to compress the spring until it gets into its regulating position. You notice it's got some chamfers cut on those valve lands. So that way they can feed lube circuits and converter circuits and so forth. So we'll reuse the retainer and the plug, but we're going to go in and put in a new pressure regulator valve. So if we look what they're doing, we've got the OE valve right here, and we've got the Transgo valve. The Transgo valve has got a longer surface. It's going to end up riding in this unused portion of the valve body bore. So if there's any wear in the valve body bore from this valve causing a leak, now this new valve is going to be riding a spot that does not have any wear on it at all because it never gets contacted. So we have to use our end plug and retaining clip, but we put in the new pressure regulator valve and spring. On this side of the valve body, they're going to want us to deal with this torque converter clutch regulator circuit. And that is one that failed us on the vacuum test that we did earlier. So that's the lineup for the torque converter clutch regulator valve that lived in that bore. Now the Transgo kit is going to be a little different. On the Transgo kit we have a spring and a valve. And then what they do is they put this scarf cut Teflon seal in this groove right there, and then you put an O-ring over that to size it down until you're ready to assemble it. They say in the instructions, once this is assembled, do not take it back out. So we got one chance to do this right. And here we'll go ahead and reuse our little slug and our retainer, and we'll take our valves, kind of put them off to the side. Let's put some trans gel in that slot for that Teflon seal. And then it's a scarf cut Teflon seal, so we want to make sure that the angled portions fit next to each other. And then what Transgo wants you to do is put this in the freezer for about 15 minutes or so, and that'll help collapse this assembly down, shrink it down. Obviously this O-ring you wouldn't leave on there, it wouldn't be able to stay on there, it'll slide off. But the idea is to get that Teflon seal to be no larger than the outside diameter of this bore when you slide it in, or else it'll probably jam that Teflon seal in there. Remember, once it's in, you can't take it back out. They say it should just push right in, and it does. Didn't have to fight it one bit. I can put my slug in there, put my end plug, then slide my retainer in. So as far as this upper valve body is concerned, I should be good. I got my new torque reverse clutch regulator circuit in there. I got my new isolator, my new pressure regulator, and my new retaining clip. This side should be good to go. Now let's look at the lower valve body. You can see we're getting down on our kit here. The only thing I have left to change now is this actuator feed limit, so I'll go ahead and slide these parts out. So these are my original AFL valve parts, retainer, spring, and valve. And this is the replacement. I got the new retainer, I got a spring and the spacer here, and then I got this valve, and this valve's got its own little bushing. So it looks like they redesigned the circuit to deal with a worn out bore. Bushing has a nice fit to it. Got my bushing in there, the spacer, the valve. And now all I have to do is install my retainer. Upgraded my AFL, which is an area that I had excessive leakage. I also upgraded my regulator, my torque reverse clutch regulator in control. One of those had excessive leakage. That updated my pressure regulator valve, my isolator valve, pressure regulator valve, and isolator valve. It's one of those things that even if while rebuilding this transmission, some of these things check out okay, for the cost of a kit like this, it's not that expensive, and it addresses some of these common areas. This is definitely a good modification to make your rebuild last, hopefully longer than the original unit did. Also included in this Transgo kit are these pressure switch films and these grommets that go in place of the pressure switches. And as I mentioned before, these pressure switches have a tendency to crack and split. It's the same thing on the 6L80. Here we got the 6070, 6075, first generation. They had pressure switches, they split, they open up, and they end up creating DTCs, putting the transmission in fail-safe. And so this is something you want to address. I will tell you, these pressure switches are kind of a bear to deal with. If you have patience, you can get it done. You pull these grommets out. Obviously, that's not a big deal, getting a grommet out. And then you fish out the film. The film is larger than the diameter of that hole. It actually tucks underneath a little bit. They're actually not that hard to get off either. You just kind of get underneath it. If they're not ruined already, you'll probably ruin them trying to get them out. If you start this process, you're going to have to finish it. And like I said, these are what splits. And when it splits, it gets pressure underneath there, and then it can't toggle the switch properly. So there's actually a switch in there. This little piece that's in here is a switch. Let's see if I can get it out. This is the plastic piece that actually pushes on that switch. So it fits inside there, it makes contact with those little fingers there. Oh gosh, it's upside down. Allows that switch to do its job. If you push down on it, you can feel the switch toggle back. Might be able to hear that. Probably not though. When we go to install these little diaphragms, these pieces of plastic, not a bad idea to go in and put a dot on the center of one of these. That way you know when it's installed it is in the center, because these are larger and they kind of tuck underneath there. Transgo says, make them like a upside down taco shell. It is around lunchtime for me right now, so I'm kind of hungry. I do like tacos. Then we'll tuck that in there. This isn't the hard part. This is actually the easiest part of the whole process. And Transgo gives you an extra one, an extra seal and a grommet, I believe. I know definitely an extra diaphragm. Okay, so when we go to install the diaphragm, this is the trickier part, because you have to get the lip. This is shaped like a hat, and that hat, the brim of the hat's got to tuck underneath the plastic, which makes it really difficult to do. So you put a little bit of, I already got it on there, but you put a little bit of gear lube on there, and then you kind of work the brim of the hat underneath this plastic plate. This is going to end up sealing off the pressure switch. When we bolt this down to the valve body's going to push on that grommet and squeeze that and seal off that pressure switch. Now, I like to, when I try to do it, I'd rather keep the excess off to the outside. I don't want to tuck it in, because what will end up happening is I'll use this little homemade tool that I've got. This tool right here is basically about a 1/2 inch tube that I drilled out with a 7/16 drill, and then I cut 1/3 of it, or 2/3 of it off, and just left this portion there. And I could push this down on the outside of it, and while I'm doing that, I'll push in on that seal. In the Transgo instructions, they say, treat it like a small child with patience. This is probably why a lot of people don't have children. So what this did is it sat on the brim of that hat, pushed it down the rest of the way. Without something like this, it seems like there's always a little nub of it sticking up. So like right now, I got that in there all the way. So the idea of the tool is to grab the brim and lay it flat so that way it can find its way into the groove. I think it's good. It looks good, sitting nice and circular there. It's not all deformed. So the way we check it is we use a washer, or in this case I'm using a little air test plate, and you push down on the center of it, put 30 psi in there. You shouldn't hear any leakage. So it's good. Now we have to do that to the 4 pressure switches, and when we're done, we'll have the pressure switch situation taken care of on this valve body, and we'll have all those modifications so we can start putting it back together. Okay, got the check balls in there. There's no dowel pins on this cover here, so before you tighten any of these up that hold the cover on, make sure everything looks centered and lined up properly. Alright, we're back at our transmission. Before I forget, let me make sure I install my speed sensor. At this point, now I got that bridge seal that's in there, verified that. I can go ahead and, I don't want to forget to put my manual valve in, that would be bad. And I can drop my valve body in. Careful not to pinch any wires. Also line up the slot right there with the manual valve linkage. Make sure it's lined up properly. All the bolts except for these two are the same size. These two right here, little shorter ones, they go in this spot. All the others go around the outside. They do have a torque sequence that they want you to use. They want you to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now we're ready to install our Techum. I love to say that word Techum. This little solenoid plate is replaceable. It comes in your kit, so you want to make sure you put a new one of those on. A little more of a variety of bolt sizes that we've got on the after we install the Techum. So don't forget that this clip right here pushes down on that TCM, so that way it kind of pushes against that heat sink that's on that plate on top of the channel casting. Don't want to forget that. The computer will probably overheat if you do. If you're not careful and you get the bolts in the wrong spot, the screw head could actually go through and deform the spacer plate. If you remember, that was kind of done on this one. The overhaul kit will also include this Techum gasket, seals through the pass-through opening in our pan, and also include a new O-ring seal that goes around the pan. If this thing doesn't want to stay in there, you can maybe put a little bit of Transgel in there to kind of keep it in place. Before we put the pan on, let's go ahead and make our electrical connections here. This is the range sensor. Tuck it down under there. This is our input shaft speed sensor. Tuck it down. We just don't want to get anything caught between the pan and the valve body. And then this is my output speed sensor. And it has a little spot where it can kind of guide right through there. And we put our oil pan on. And there is also a torque sequence for the oil pan. So we went through and rebuilt this thing, or simulated a rebuild, taking it completely apart, looking at things like the pump, the gear set, the clutch packs, how it assembles. We looked at the fact that it really didn't need that many special tools, and some of the tools that it does need we can fabricate on our own. And then we went through the valve body pretty thoroughly and did some vacuum testing, and even changed and put a Transgo shift kit in it. So hopefully if this thing goes in a vehicle, which it won't because it's a lab unit, but if this thing ever went in a vehicle, it would last for millions of miles. This video is sponsored by Transtar Industries, the leading distributor of automotive aftermarket parts and solutions. Transtar has been helping technicians since 1975, focusing on quality parts with unmatched availability and excellent customer service. Visit www.transtar1.com to learn more. That's Transtar1 with just one S. I want to say thank you to Transtar for providing a kit for this transmission so that I'd have something to show when going together with it, what a typical rebuild would include. I also want to say thank you to Transgo for providing me with a kit to go through and modify the valve body so that way we get to see what all goes into. I want to say thank you to Transtar for providing a kit for this transmission so that I'd have something to show when going together with it, what a typical rebuild would include. I also want to say thank you to Transgo for providing me with a kit to go through and modify the valve body so that way we get to see what all goes into improving these transmissions, especially the ones that have many miles on it.